Hello, I'm Professor Mohammed Ali Almomani from the Industrial Engineering Department at Jordan University of Science and Technology. In this Materials Alive video, let's visualize how a screw dislocation is created. When relative shear occurs across a slip plane, one part of the crystal is displaced relative to the other. At the atomic level, the surrounding lattice adjusts continuously to accommodate this displacement. This two-dimensional picture is only a simplified representation. In a real crystal, the displacement develops in 3 dimensions around the dislocation line. How can we visualize this? Think of a spiral parking ramp. After one complete turn around its central axis, you arrive at a different level. A screw dislocation behaves similarly. The atomic planes form a helical arrangement around the dislocation line. After one complete circuit, the lattice is displaced by one Burger's vector, b. The physical atomic model helps us see this spiral arrangement more clearly. And here is the key feature to remember. In a screw dislocation, the Burger's vector is parallel to the dislocation line. This parallel relationship is the defining characteristic of a